Good morning, everyone. It's so nice to see a full class. I have a good news. The good news is that with my second class yesterday, we decided to move the exam date from Tuesday to Thursday. Yeah, because we have so much materials for you to digest, so it will be easier if you have one more extra day. So our exam will not be Tuesday, it will be next week, Thursday. And today we are going to decide up to which section. Today we are going to decide up to which section our exam. So today will be the last materials for the exam. And on Tuesday, if you have a question, I'll go over those as a review. And if you don't have any question, I'll keep doing chapter 6, but those materials will not be in the exam. So your exam will be based on up to our today's materials. Okay? Any question? So in our last class yesterday, we started chapter 6, and I gave you this list where we have all the information what we are going to learn in this chapter 6. So we are going to factor 2 terms, 3 terms, and 4 terms. We finished with 2 terms. When we talked about 2 terms, we said there are only 2 choices. Either we can pull out a GCF as a common factor, which is the greatest common factor, or we have difference of perfect squares. So if you pull out a GCF, what remains in our factor, in our polynomial, is if you divide each term by the GCF, you left with whatever we get after you pull out the GCF. And then we did several examples. So in the first one, we had 4 GCF. So when we factor out 4, we divide the first term by 4, we get t. Second term by 4, we get 3. Here, there is no visible GCF, but anytime you start your polynomial with a negative sign, you always have to take it out. Not have to, but you should. You always should take it out as a common factor. So you take out -1 as a common factor, and when you divide -x by -1, you get positive x. Positive 2y by -1, you get -2y. So we still have the same 2 terms, just their sign different. And then we did few of these, and then we had a second scenario where we have difference of perfect squares. It means we have 2 perfect squares, either they're variable or they're numbers, and you have a negative sign between them. That's why that's called difference of perfect squares. So for difference of perfect square, our factors are 2 conjugates. What are the conjugates? You take the square root of each quantity, and then whatever you get, you add them, subtract them. And we did few examples. And then we have the same thing, but there's a GCF in the front we can pull out. So anytime you have any type of polynomial, you always should ask yourself first, can you take out anything as a GCF? If you can, you should always take it out. So in these 2 examples, in the first one, we have 9 as a GCF. When you factor out, we left with 4a squared minus b squared. And now they both are perfect squares. So square root of 4 is 2, square root of a squared is 8. So from the first term, we get 2a, and square root of b squared is b. So we get 2a and b, so you add them, you subtract them. And don't forget about the GCF. The second one, we have 2 as a common factor. So when you factor out 2, we get 8 divided by 2, which is 4x squared, 2 divided by 2, which is 1. Now, whatever we get after GCF, these are still factorable because they are difference of perfect squares. So again, square root of 4 is 2, square root of x squared is x. So from the first term, we get 2x, and square root of 1 is 1. So we have 2x and 1, you add them, you subtract them. And then there are some scenarios where we have double perfect squares. So for double perfect square, we have to apply the factoring twice. So you do the same thing. You start with square root of each quantity. So square root of x to the 4. It means you're dividing this 4 by this 2. Square root means you have a 2 invisible inside your radical symbol. So 4 divided by 2 gives C square power. 4 divided by 2 gives C y square power. So we have x square and y square. Add them is subtract them. Now for addition, there is no rule. We don't have any sum of perfect square rule. We always have difference of perfect square. So for sum, it's not factorable, we bring it down. But for difference of perfect squares, it's factorable. So you take the square root of x squared, which is x, square root of y squared, which is y. So you get x from here, y from here, we add them and subtract them. So we apply difference of perfect square twice. That's why they're called double difference of perfect squares. Same thing, the other one. And then for sum of perfect squares, there is no rule. When you cannot factor your polynomial anyhow, we call those polynomial prime polynomials. Just like prime numbers, 3, 2, 5. Those are prime numbers. Why? Because we cannot factor them besides 1. So same thing, whatever polynomial is not factorable besides 1, we call them prime polynomial. And then 4 terms. We are going to start today's lecture with 4 terms. I did that yesterday with my other class. Let me erase this. For 4 terms, there are also 2 choices. Either we can pull out a GCF, and whether we can or cannot, it doesn't matter. At the end, we have to use a grouping method to factor our 4 terms. In grouping methods, what we do is we group. So let's start with easy ones. When you have 4 terms, we put 2 terms in one group and another 2 terms in another group. And then we keep factoring individually each group, and then we do it twice. So step 1 is always look for GCF. In C, we have 2x minus 2 plus x cubed minus x squared. This actually will not be in the final. So in all 4 terms, do you see any GCF? Like, is there anything that all 4 terms have? 2 is visible only the first 2 terms. I'm talking about the right one, sorry, not the left one. Actually, I should do this. Or never mind. The left one is a little bit harder, not harder, like more factoring. So I'll start with the right one because it is simpler. So when you look at C, there is no GCF that exists in all 4 terms. So that means we have to go to the grouping directly. So what we do, we group them. We take any 2 terms and we group them into one group. So here, which is the first 2 terms, this is our group number 1. So this is our group 1. And combining second 2 terms, we have group 2. That's why this is called grouping method. We group them into 2 groups. And then we take our GCF from each group. So in the first group, do you see any GCF? What is the GCF here? 2. So we factor out 2. Then what is left in the first group? X minus 1. So again, how do we get x minus 1? 2x divided by 2 is x, minus 2 divided by 1, 2 is minus 1. So when you factor out anything, the remaining term we get by dividing all the terms by the GCF. And now in group 2, do you see anything in common in group 2? X squared. Since our group started with plus sign, so we are going to keep plus and then x squared. So once you factor out x squared, now what is left in group 2? X minus 1. We still have our same 2 groups. Group 1 and group 2. So step 1, factor each group individually. And step 2 says, now you look at both groups and see, do you have anything in common? So in group 1 and group 2, do you see same thing? What is x minus 1? So you factor out x minus 1. Then what is left in the first group and second group? Plus x squared. So factor 1 individually, factor 2, do it together, and then at the end, write them as two factors. Now, this one has nothing to factor out. How about this one? Is it factorable more? Do you see any common factor between 2 and x squared? So none of these are factorable, means we stop, and this is our final answer. The GCF between x cubed and x squared. Now, x cubed, it means how many x you have? How many? 3, right? 1, 2, 3. X squared means how many x you have? 2. Now, how many number, what's the most number of x you have in both of them? 2. That's why this is GCF. GCF means greatest number, greatest common factor, or greatest number that you have in all polynomials. Our GCF is x squared. So for variable, if you have same base with multiple powers, our GCF is the smallest one. But for numbers, you look for factors. That's the biggest number that divides all the numbers. Any other question? Now apply the same concept. We are going to do the first one. But before we start the grouping method, what do you always look for in any polynomial? GCF. So do you have any GCF this time? What's the GCF? 2, not square. The middle second term doesn't have square. The first 2x doesn't have square. They all have 2 in common. So we factor out a 2. That's our GCF. So what is left? Go ahead. No, the first term. What is left here? X minus 1 minus x cubed plus x squared. So anytime you have a GCF, factor that out. And now we go to the grouping method because we have 4 terms. So we take first 2 terms and you combine to group 1. Second 2 terms, it combine to group 2. G means group. I have to lazy to write group. So we still have our GCF. Now in the first group, do you see anything in common? They have nothing common, means they have 1 in common. Anytime you have nothing, it means you always have 1. So we factor out the invisible 1. And what do you have in group 1? X minus 1. Nothing changed because we didn't do anything. Now we go to the second group. What do you see in the second group in both terms? X squared, definitely. And how, with what sign your second group starts? Minus. So anytime your polynomial start with a minus, what do you have to do? Factor it out. Our first group did not start with minus, so we didn't have to pull out a minus, but our second group starts with a minus. That means we have to take out minus, and then our GCF is square. Now, once we factor out the negative x squared, what do we have in our second group? X and then minus 1. So if you're wondering how we have that, well, we have it because our second group is negative x cubed, positive x squared. We factor out negative x squared, means we are dividing by negative x squared. So we get x here and -1 here. Again, the first thing is our group 1, and the second thing is our group 2. Any questions so far?
For that one, you used the grouping method. You didn't use the one as a GCF.
Because we have more than 1 in here. If you look at the first group, there was a 2 in it, so we factor out 2. In the second group, there was x squared in it, so we factor out x squared. But here, in this group, we have x and 1, there's nothing in common. So we factor out 1 because we have to factor something out. Anytime we don't have anything visible to factor out, you can always factor out 1. And if the polynomial starts with the minus sign, you factor out -1. Now, if we still have our 2 as GCF, and now if you observe 2 groups, do you see the same thing in both groups? What do you see? So we factor out x -1. Then what do we have in the first group? 1, and the second one is x squared. Any question? Now, 2 is already factored out. It has nothing to do. And x -1, they have nothing in common. So we're going to worry about that. But how about 1 minus x squared? Can we factor that more? 2 terms, what 2 choices we have? Either a GCF or what? No, grouping is for 4 terms. For 2 terms, there are only 2 choices. One is GCF. What's the second one? Difference of perfect squares. So there is no GCF here. So it's not a GCF concept. How about difference of perfect squares? Is 1 a perfect square? Yes, because 1 square is 1. Is x squared a perfect square? Of course, because it's square. Anytime your variable has an even power, it's a perfect square. So we do have a difference of perfect squares here. Difference of perfect squares. So how do you factor difference of perfect squares? One plus x and 1 minus x. So you take the square root of the first element, which is 1, square root of the second element, which is x. You add these 2 things and subtract them. And you get your difference of perfect squares, the factors. We still have 2 as GCF, and we still have our x -1 from the beginning. So now it's done. It's factored completely. So here we actually use 3 methods: GCF, grouping, and difference of perfect squares. Anytime you have something more factorable, then you have to keep factoring over and over and over until it's not factorable anymore. And we are not going to combine x -1 with 1 minus x because their positions are different. In one factor, we have 1 minus x. In the other factor, we have x -1. So you can simply leave that alone. Any question? Good news, there will be only 1 question in the exam with 4 terms. And most likely, the first type, C, B. why you have to keep factoring over and over and over and over. It's okay if you don't. You don't have to put the bracket or parentheses. I kept doing it up to here, then to show you that this is here, and you still have to keep grouping or both times. But once you are done here, it means 2 times that times that. So they all are multiplying one another, so it's fine. Any other question? So one of these will be in the exam. Good news, in the final exam, they don't have this type of question. This is only for our in-class exam. Now you try one, the easy ones. And then we're going to start 3 times. And why did I put my Do any of you have your reflection to give me if you did not upload yesterday? The exam reflection? Any other exam reflection? Remember, these exam reflections are 3 points. You don't have to work alone. You can talk to your neighbor. Then it's fine. And 30 is 36. 3626, 3626. What a good day today. Alexander. Anna. Anastasia. Restaurant. Axel. Eileen. Brenda. Christopher. George. Hannah. Hodo. Jaseline. Jesus no phone. Jody. Jody. Kevin. Christina. Lily. Lily, how come you were absent for last 2 days? Are you okay?
Yeah.
Liz Mary. Michaela. Marlinda. Norel. Natasha. Patton. Phil. Renan. Sarah. Shawis. And Yusuf. Absent. So I have absent Eileen, Brenda, Jody, and Yusuf. It's done. Anyone else? You, what did you do first? So do you see same thing exists in all four terms? 5 is not divisible by 2. So there is no number. How about x? Do you see x in all four terms? The last one doesn't have x. Do you see y in all four terms? So do you have any GCF? Then what do you do? So we found no GCF. So for four terms, what's the method? The name of the method? Grouping. So you group. That's why this is called grouping. Group 1, group 2. Kevin, do you see anything in common in the first group?
Yeah.
What do you see? 4. And how about the variables? Any of the variables? X. So if you factor out 4x, what is left in the first group? So factoring out means you're dividing. So if you divide 4x squared by 4x, what is left in the first term? No, x to the 1. 4 cancel out, and 2 power minus 1 power gives you 1 power for the x. Okay, and if you divide the second term by 4x, now what is left in the second term in the first group? Kevin. Good job, 2y. Christopher, right? So what do you see in the second group? 5 doesn't have any 2. So positive 5 or negative 5? We have to start with negative 5 because our second group starts with a negative sign. So is there any variable we can factor out? So what is left in the second group? Remember, factoring out means you are dividing by your factor. We have x. You have 10y. Plus or minus. You have plus 10y and you're dividing by negative 5. Minus 2y. So we still have our group 1. We still have group 2. Pattern. What do you see in both groups? So we factor out x minus 2y. Then what is left in the first group? 4x. And in the second group? Minus 5. Jesus, can you factor anything from x minus 2y? Can you factor anything from 4x minus 5? So what do you do? We box our answer. This is the final step. We cannot go any further. That's it. So sometimes our life is very easy. Sometimes our life is a little bit complicated, like the first example. Any question? Negative 5. If you look at the group 2, our group starts with negative 5x and then plus 10y. Anytime you start a polynomial with a negative sign, it factors that out. So our second group, the polynomial is negative 5x plus 10y. We start with negative sign, so you have to factor out negative. And now between 5x and 10y, there is only 5 in common. So factor out negative 5. Now we have negative 5x, it factored out negative 5. So negative 5x divided by negative 5, they cancel out, you get the x.
But factor out, you divide.
Factoring out means to see what remains is you have to divide everything in the polynomial to see what is left. And when you distribute that again, you're supposed to get the same thing back. Any other question? So that's how we divide 4 terms, and there's only one question in the exam. And now comes 3 terms. For 3 terms, there are 4 choices, 4 ways. The first one is always GCF. Anytime you are supposed to factor anything, you always should look for GCF. So we have negative 2x squared y minus 30xy plus 34y. If you look at all these numbers, we have negative 2, negative 30, and positive 34. Is there any number by which you can divide all 3 numbers? So what is our GCF for the number? Negative 2. We have to factor out a negative because our polynomial starts with a negative. And then if you look at the variable, we have the first one is x squared y, second one is xy, and the last one is y. That means our GCF in this polynomial with 3 degree is negative 2y. Let me actually put a little bit lower. We have negative 2 for the number, y for the variable, and then we write what is left. So in other words, you are going to divide all of this by negative 2y, negative 2y, negative 2y. Liz Mary, after factoring out negative 2y, what is left in the first term? See, to make your life easier, I already put negative 2y on the division sign. X square. So we cancel out this negative 2, this negative 2, and y with the y. The only thing we have left with is x squared. Great. Sarah, what is left in the second group? So enough group, second term. Positive or negative? Positive. So negative 2 goes to negative 30 15 times. Y cancel out. We get 15x. Michaela, the last one. We have 34y and we factor out negative 2y. Positive or negative? Negative. So 2 goes to 34 17 times with a negative sign, and y cancel out. So we have negative 17. And for now, we stop. We factor out GCF. For now, we stop. But later, when you're going to learn how to factor this, we're going to factor more. Any question? So it wasn't too bad, right? Now we are going to learn how to factor this middle thing, the x squared plus 15x minus 7, if it's factorable. So our second scenario, we have x squared plus bx plus c. So it's a quadratic expression, and there is no coefficient in front of x squared. So if you don't have any number in front of x squared, That way we factor is we look for two numbers. If you multiply the two numbers, the result will be C. And if you add the two numbers, the result has to be B. So always figure out two numbers. If possible, they have to multiply to C, add to B. If you can't find such numbers, then our factors are easy. We write them as two binomials, and we have x, and then we write down those two numbers. Whatever makes the product C and sum to B. This is the ruling. X squared plus bx plus c. We can factor this directly into two polynomials, just like difference of perfect squares. When we had difference of perfect squares, we could always factor into two binomials by adding and subtracting their square root. Same thing here. When we have a trinomial, we can factor this way if possible. If you can find two numbers, multiply to C, add to B. If you cannot, that means not factorable. For example, in the left one, we have 17. So two numbers multiplied to 17 are only 1 and 17. 17 is a prime number. So if you try to factor this, 17 has 1 and 17. If you add them, we get 18. If you subtract them, we get 16. But our middle term is 15. So can you factor the left page anymore? Because we could not find such numbers. Multiply to constant, combine to middle term. Now here, can you find such two numbers, multiply to 5 and add to -4? What two numbers you get? 1 and 5. Now multiply to -5 because our constant is -5. So let me actually do this way instead of writing this. What two numbers, when you multiply them, now let me do it on the side, otherwise you'll think this is a process. Must do. So two numbers multiply to -5 and add to -4. We know it's definitely 5 and 1. Now 5 times 1 is +5, but we have -5. So what sign we must have in front of which one, so that when we add them, the result is -4. -5. So the two numbers you're looking for is -5 and 1. -5 times 1 is -5. -5 plus 1 is -4. So once you figure out your two numbers, your life is easy. All you have to do is put them together as a binomial. We write x and x for both. So x times x is x squared, and our 5 is -5 and +1. I should also mention something that the biggest factor always get the middle sign. That's the trick. Whatever middle sign you have, the bigger factor you find, they have to have the same sign. So between 5 and 1, 5 is bigger. So 5 has to be negative because our middle sign is negative. How about the next one? Jocelyn. Two numbers multiply to -10, add to -3. X minus 5, x plus 2. So we know 5 times 2 is 10. 5 plus 2 is 7, but we want a negative. Since our middle sign is negative, so 5 has to be negative. And that's it, we're done. This is called direct factoring method. We don't have to do anything complicated to factor them out. We factor directly from the trinomial two binomials. Any question? Okay, I have a few, try them. You don't have to try alone, you can work with your neighbors. Do I have more? I have more. Do I have more? No. So if you want to see the last page, when you get that. So in other words, what we do is we split our x squared into two pieces, and we split our constant into two pieces. So 2 pieces for x squared goes here, and 2 pieces for constant goes here. That's what we do always. Yes. Bless you. Easy. No wonder he explains so well. Okay, anesthesia, F. X minus 3, X minus 2. So let's verify. Negative 3 times negative 2 is positive 6. Good. Negative 3 minus 2 is negative 5. Wonderful. Perfect. Malinda, the next one, G. X, let me read here first. X plus 3 and X plus 2. So 3 times 2 is supposed to be 6, but we have negative 6 minus 3 times 2 is minus 6, but minus 3 plus 2 is negative 1, not 5. But we have negative 5 in the middle. Excel, negative 6 and 1. Let's verify. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. Yep. So this is actually minus 6 and plus 1. So see, these two are tricky. They look almost same. The only difference is the negative sign in front of 6. The first one is a positive sign, second one is a negative sign. Because of only difference, they have completely different factors. So you always have to verify that your scenario. Multiply to constant, add to the middle term. So this one we got wrong, this one we got correct. Alexander, the last one. Split it x squared. So what do you get? If you split your x squared into two pieces, oops. This looks hard, but actually this is not hard. If you split x squared into two pieces, what do you write? X and x. Now split your 9y squared into two pieces. So when you add them, you get positive 8 in the middle. How can you split your negative 9y squared so that in the middle you get positive 8? You can ignore the x. You can only look at the split your y squared. Easy. Split your y squared. How are you going to split? Forget about the 9. Split the y squared. Y and y. And now split the 9. Negative 9 into two pieces. So that multiply to negative 9, add to positive 8. One and 9. Okay. Now you have to decide the sign. Multiply to negative 9, but add to positive 8. Remember the thing I said before? The bigger factor has to get what sign? The middle sign. Not negative, middle sign. Anytime you have your two factors and you get confused what sign you're supposed to get, remember the middle sign goes always to the bigger ones. So between 9 and 1, which one is bigger? 9. So what sign 9 has to have? Plus. So if 9 is plus, 1 has to get what sign? Plus or minus to get 8. Minus. So 9 times negative 1 is negative 9. 9 minus 1 is positive 8. You look at the numbers and you split your variables. X squared, we get x and x. Y squared, we get y and y. Now if you look at only the numbers, we have only two choices. 9 times negative 1 and 9 minus 1. Good news, this will not be in the exam, but this will be in your homework and quiz on my MATLAB. Any question? Exam now. I'm going to give you these, the easy ones in the exam, not the difficult one. George, the next one. We have 54 plus x squared plus 15x. What do you think our first step should be? There is no GCF. So we go to the next step. What is our next step? Remember, it's a three times polynomial. So you always have to, you want to have your polynomial start with what? Which term? If you observe all the rest of the polynomials, you start with which term? One is the number, and what's the variable? X squared. So every second degree polynomial, you want to start with x squared. Do we have x squared in the first term? So what is our first term? Rewrite it so that we have x squared first, and then our 15x, and then our constant 54. So here are to factor a quadratic. We want to have the quadratic format. The quadratic format is ax squared plus bx plus c. This is what you want. In here, our a is invisible, which is 1. And now we can go factor easily. We split x squared into two pieces. So how are you going to split it x squared, George? Divided x squared into two pieces. How are you going to divide it? X and x. And now you're going to divide your 54 into two pieces. So how are you going to divide that? Multiply to 54, add to what number? 15. Can you find such numbers? 9 and 6. So 9 times 6 is 54, 9 plus 6 is 15. So what sign they both have? Plus. And that's it, we are done. You split the variable into two pieces, you split your constant into two pieces, and you combine them by observing the middle term. Now, following the same concept, we are going to have two factors for the last one. Split your first term into two pieces evenly and split your constant term, split your constant term two pieces evenly. So who'd like to try this one? Meryl. Negative 7 times 2 is negative 14. Good. Negative 7 plus 2 is negative 5. The middle term, perfect. So you factor on negative 7 and positive 2. And how about your variable? If you split it x to the 4 into two pieces evenly, each piece supposed to get what? What times what going to give you x to the 4? You have 4 of them, right? 1, 2, 3, 4. If you want to split them evenly, each one's supposed to get how many x's? 2. So x squared and x squared. And now we know x squared is perfect square. Good. Is 7 a perfect square? No. Is 3 a perfect square? No. 4 is a perfect square. 1 is a perfect square. But 2 is not. So we stop because we cannot factor anymore. But sometimes it's more factorable. This definitely will be in exam, probably not in this exam, but in the next exam. So this actually comes in the final exam. In the final exam, it will be factorable twice. So with this, we are done with direct factoring method. And now the last concept for our exam is the next one, AC method. We call this method AC because we have to multiply A with the C. So A is the coefficient in front of x squared and C is the constant. There are several ways to use AC method. One is a formal AC method and one is I invented. Actually, not I invented. I modified some weird method into this method. It's called weird AC method. The name I invented actually, weird AC method. So we use AC method when x squared has a number in front of it, when x squared has a number in the front. So if you observe all these examples we did, x squared did not have any number in the front. So we went and factored directly. But now if you have a number that is visible in front of x squared, you have to choose AC method. Now in this weird AC method, what we do is we rewrite ax squared plus bx plus c into x squared plus bx plus ac. Instead of writing c, we write ac, and instead of writing a in the front, we just make it invisible. Why do that? Because we observed already so many examples that if the x squared doesn't have any number, we can factor easily. So you have to factor directly. We make our a invisible. Instead, we multiply c with a and write ac. And then we do the same thing what we did before. Find two numbers, multiply to ac, combine to b, put them here, including their sign. And then at the end, we have to make our a visible somehow. So what we do, one of these two numbers will be divisible by a. Always. Whatever is divisible by a, you divide that number by a. And for the other factor, you multiply with x by a. And you are done. Second step, first step, make your a invisible and rewrite c as ac. Factor, one of the number will be divisible by a, divided by a. And whatever is not divisible by a, multiply the variable by a. For example, 2x squared plus x minus 21. Now, x squared is not alone. It has a number 2 in the front. So we are going to use AC method. Now we're going to use weird AC method, because this is actually much easier than normal AC method. So step 1, let me change the ink. We rewrite C as AC and we make the A invisible. So x squared plus x minus, no more 21, we multiply 2 times 21. What is 2 times 21? 21 times 2, 42. And now we factor. So step 2, factor. Find two numbers, multiply to negative 42, combine to positive 1. So we split our x squared into 2 pieces, and we split our negative 42 into 2 pieces. So can you figure out two numbers, multiply to negative 42, but add to positive 1? 6 and 7, right? 6 and 7. So we get 6 and 7. And what is our variable? X. Now, what is our sign? Between 6 and 7, which one is positive? No, the bigger one. The bigger one must be positive. Or if you're used to seeing the other way, let me write 7 here and 6 here. So middle sign always have to go to the bigger factor. We know we have 7 times 6. Middle sign must go to the bigger one. Then what sign 6 has to have? Plus or minus? Minus. So we factor directly, and now we are going to bring our coefficient 2. Now between 7 and 6, which one is divisible by 2? So we divide this. Actually, let me do it in the next step. Come on. Step 3, we have x plus 7, x minus 6. 6 is divisible by 2, so we divide this by 2. And 7 is not divisible by 2, so we multiply the x by 2. And we got our final answer. 2x plus 7. And what's the second factor? If we divide 6 by 2, what do you get? Negative 3. And ta-da, we are done. In order to check whether they're correct or not, You can always distribute and see if you get the original thing back. So let me do the checking here. Check. We have 2x plus 7 times x minus 3. 2x times x is 2x squared. 2x times negative 3 is negative 6x. 7 times x is positive 7x. And 7 times negative 3 is negative 21. If you combine negative 6x and positive 7x, we get 1x. So we have 2x squared plus 1x plus minus 21, which is the exact same thing what is given to us. 2x squared plus x minus 21. That means here, the two factors we got, they are correct. So in your exam, let me take out the review sheet. So definitely we'll have 5.1, 10.2, 5.2, 3, 4, 5. We did direct factoring 6.12. We did not do 6.3, so 6.3 will not be in this exam. But we did AC method and difference of proper squares. So everything from the review sheet will be in the exam except the trial and guess method 6.3. So you have your homework 6.1 to 4.5. You can just skip 6.3. So start doing your homework so that you can have practice for your exam and you're doing the homework at the same time. Okay? So enjoy your homework. You have chapter 5, chapter 6 homework. Especially you have chapter 5 due earlier than chapter 6. So start with chapter 5 and then go to chapter 6 for homework and quizzes. Have a good weekend. Be safe. Bye.